Hello everyone, welcome to my channel Matrix Edu Universe. In this channel, I will give a very detailed explanation of all the lessons of class 10 mathematics. Today, I am going to discuss with you areas related to circle. Let us start. We all are familiar with a circle. How can we define a circle? It is a collection of all points in a plane which are at a constant distance from a fixed point. And this fixed point is what we call the center of the circle. Usually, we are representing the center by the letter O. If we have a circle in a plane, we can locate a point in three positions. You can locate a point in the interior of the circle, in the exterior of the circle, and you can also mark a point on the circle. I am going to mark a point on the circle, let it be A, and I am joining the center with that point. And by definition, we all know from smaller classes onwards we are studying the line segment joining the center to any point on the circle is radius, and that is usually represented by the small letter r. Now I am marking another 2 points again on the circle. Let it be x and y. And now I am joining them with a line segment, and this is what we call the chord of a circle. That is the line segment joining any 2 points on the circle. If that line segment passing through the center of the circle, here PQ I marked on the circle, and definitely that PQ is a chord, but this is a chord passing through the center of the circle. So this chord is what we call the diameter of the circle, and diameter of the circle is the longest chord of a circle. And at the same time, since the circle is the collection of infinitely many points in a plane, a circle can have infinitely many radii and diameters and also chord. But the diameters are all of equal length, and also the radii also are of same length. Okay, and when you look into this diameter PQ, it is usually we are representing diameter by the letter D. It is the sum of OQ and OP, and OQ is the radius of the circle, the line segment joining center to any point on the circle, that is Q, and OP also another radii. Okay, I already told a circle can have infinitely many radii. So let it be R, and this OP is another R. So R plus R, that is diameter is equal to 2 times R. Okay, and the next point is, what is the circumference of a circle? The circumference of a circle is the distance around the circle. Suppose an ant is moving along this path. After completing one complete revolution, the distance travelled by the ant, that is equal to the total distance around the circle. Okay, that total distance around the circle is what we call the circumference of the circle. Usually we are representing circumference with the letter C. Okay, you can take a circle with a string and you cut along that circle at one point. So you can easily measure the length of the string, that is equal to the circumference of the circle. Okay, and before that you measure its diameter and take their ratio, that is the circumference and the diameter, the ratio between the circumference and the ratio. And in the next time you take a circle with a different radii or the diameter compared to the first one, and at the same time you just take the ratio between the circumference and the diameter of the second circle also. And you can take the third case, okay, another circle with a different diameter, and all these cases you can see that the ratio is a constant, and this constant value is we are going to represent by the letter, that is Greek letter, that is pi. Okay, that is what I said. The ratio between the circumference and the diameter is always a constant for any circle with a different diameters. Okay, so this is equal to pi. Okay, and in order to derive the formula for the circumference, you keep this circumference C in LHS by taking D to RHS, that is pi D. Okay, this is the circumference. To calculate circumference, you can use this formula pi D in terms of diameters. As we know, diameter is 2 times R. Instead of D, you can substitute 2R. Okay, usually we are taking the constants as the coefficient by writing the variable. After that, that is C is equal to 2 pi R. This is the circumference of a circle in terms of its radius. The another term related to circle is the arc of a circle. What is an arc of a circle? It is nothing but a part of a circle or a piece of a circle. Here I have drawn a circle with the center O, and I have taken 2 points on the circle and I joined the end points with the center of the circle O. And this portion of the whole circle, that is apart from the whole circumference, this is what we call the arc of a circle. An arc of a circle can be represented by this symbol. This is the representation of arc AB. This is line segment AB. Okay. So, the arc is a part of a circle. The next term is what is the sector of a circle. For that, I am taking this portion. This is the region enclosed by 2 radii and its corresponding arc. So, the region enclosed by 2 radii and its corresponding arc is what we call the sector of the circle. Okay, is it clear, children? That is the region enclosed by 2 radii and its corresponding arc. Okay, what about the other side of this circle, this sector? This is the region. This is also the region enclosed by 2 radii and its corresponding arc. Okay, so this is also a sector of the circle, but compared to the first sector, this covers the major portion of the circle. So, it is what we call the major sector of the circle. Okay, major sector, and this is the minor sector of the circle. Okay, so this is very important term, that is what is the sector of the circle. The another term related to circle is the segment of a circle. For that, I am going to mark 2 points on the circle. Let it be P and Q. And I am joining them by a line segment. Okay, here I am marking this region enclosed by the chord PQ. PQ is a line segment joining any 2 points on the circle, so it is a chord of the circle. And I have taken the corresponding arc of this side of this chord. Okay, chord PQ. So, this shaded region is the area enclosed by a chord and its corresponding arc. The corresponding means this side. Okay, the arc which includes the end points of the chord. Okay, so this is the region enclosed by the chord and its corresponding arc. So, it is called the segment of a circle. And what about the other side of the chord? This region also enclosed by a chord and its corresponding arc. See the end points. Okay. So, this is also a segment of a circle. In the case of sector, this is the region which covers the major section of the circle. So, it is called the major segment. Major segment, and this is minor segment. Minor segment. Okay. Okay. So, these are the areas related to circle. Okay, so we all know the definition of the formula of area of a circle. Usually we are representing area of a circle by the letter A. Whatever the area, we are representing area by the letter A. Area of a circle is, everybody know, that is pi r square. Okay, and if we want to calculate the area of the semicircle, that is the diameter which divides a circle into two halves. Okay, that is, you take the half of the area of a whole circle, that is pi r square by 2. This is the area for semicircle. If you want to calculate the area of a quadrant of a circle, quadrant means 1/4. Okay, that is area of a quadrant of a circle is pi r square is the area of the whole circle divided by 4. This is the area for calculating the quadrant of a circle. Okay, so this is for semicircle and this is area of the whole circle pi r square. Okay, and the terms which I have already explained, that is sector and the segment. How can we calculate the area of a sector and area of a segment? That is the heading of the lesson, areas related to circle. These are the three areas already related, and we know, we all are familiar with the formula, how to calculate area of a circle, area of a semicircle and area of a quadrant of a circle. The next areas related to circle are area of a sector and area of a segment. Before explaining the formula for calculating area of a sector, we should know how to calculate the arc length of a circle. Usually the arc length of a circle is represented by the letter L. For that I have marked 2 points on the circle and they are connected, and I have taken AB, a portion AB from the whole circle, from the circumference of the circle, a part of a circle. And in order to calculate this arc length, you just connect the endpoints of the arc at the center O. Here theta is the angle subtended by the endpoints of the arc at the center. Okay, this is the angle subtended by the endpoints of the arc, the required arc length AB. Okay, out of the 360, the whole angle, that is the complete angle 360. Okay, the angle subtended by the arc at the center is theta, that is the fractional form is theta out of 360 of, we have taken that the whole circumference 2 pi r from 2 pi r. Okay, that is theta by 360 of 2 pi r. This is the formula to calculate the arc length L of any arc, isn't it? That is theta by 360. Out of 360 we are taking only the corresponding angle, that is theta out of 360 of the total circumference, that is 2 pi r. Okay, definitely you can reduce this 2 with the 360, that is the L is equal to theta by 180 into pi r. This is the least form. Okay, 180, 2 in 360. Okay, this is the formula to calculate the arc length of any circle. Okay, and if the endpoints of the arc subtends 180 degree at the center, this is the angle. Okay, so what is the arc length of this PQ? This PQ, this is the exact half of the whole circumference, that is 2 pi r by 2, that is pi r. Okay, that is the arc length of a semicircle is pi r. Okay, if theta is less than 180 degree, you can use this formula, that is theta, either theta by 360 into 2 pi r or the reduced form, that is theta by 180 into pi r. Okay, so this is the formula to calculate the arc length of a circle, that is theta by 180 into pi r or theta by 360 into 2 pi r. Next I am going to explain the area of the sector of a circle. For that I have marked a sector okay, with a circle with the center O and radius r. Okay, this is the region whose area is going to be calculated, and here the angle subtended by the endpoints of the arc at the center is theta. Since we need the area enclosed by this region, that is in terms of the theta, that is we required the area for the angle described by theta, that is out of the whole angle, that is theta by 360. Out of the whole area is pi r, okay, that is theta by 360 of pi r square. This is the area for calculating the sector of a circle. Okay, if you rewrite this theta by 360 as theta by 2 into, instead of 360, can we write this as 2 into 180 into pi r square, can be written as pi r into r. Okay, and I am taking from this theta by 2 into 180, 1 by 2, okay, and theta by 180 degree into pi r, I am making a pair group, and into r. Okay, and what is theta by 180 into pi r? This is arc length, that is 1 by 2 into L, arc length usually representing by the letter L, and the remaining r into r, or area of a sector now reduced into this formula, that is 1 into L into r, that is LR by 2. This is the another formula for calculating area of a sector. Here L is the arc length, r is the radius, and by 2, 2 is a constant definitely. Okay, that is if you know the arc length and the radius of a circle, you can easily calculate area of a sector. See, this formula is free from the angle measurement. If you don't know the measurement of the angle subtended by the arcs at the center, you can easily calculate the area of the circle. But if you know the angle between the two radii, you can easily calculate the area of the sector by using the formula A is equal to theta by 360 into pi r square. Is it clear? These two formulas are very important. Here we can calculate area by using arc length into r by 2, provided we should know the arc length and radius. Here definitely we know the radius and theta also. The remaining 360 and pi are the constants. Okay. Next we are going to discuss the area of the segment of a circle. Compared to arc length and the sector of a circle, this formula is little bit difficulty. Also for deriving the formula is not that much needed for this year. Okay, so I am just directly giving the formula to calculate the area of the segment of a circle. That is, I already told, usually we are representing any area by the letter A, and area of the segment of a circle can be calculated by pi theta by 360 minus sin theta by 2 into cos theta by 2. Write this whole expression in bracket into r square, into r square. Okay, here pi theta, theta is the angle 360 degree, minus sin theta by 2 into cos theta by 2 into r square. So children, this is very lengthy formula, so it should by heart very carefully. Okay, but we can further reduce this formula. That is, this year we are going to calculate the area of segment when theta is equal to 60 degree and when theta is equal to 90 degree. 120 degrees deleted from the whole portion. Okay, so when theta is equal to 60 degree, I am going to explain first the area of the segment for theta is equal to 60 degree. So here definitely you have to substitute for theta 60, that is pi into 60 for theta is equal to 60 degree. What will be the area of the segment? So A is equal to pi into 60 degree by 360 degree minus sine 60 by 2. Sine 60 by 2 means 30 degree into cos 30 degree into R. Okay. R is variable, different from circle to circle, problem to problem. Okay, so 60 and 360 6 times. So pi by 6 minus sin 30 value 1 by 2 and cos 30 sin 60, that is root 3 by 2 into R square. Okay, or pi by, this can be further reduced, pi by 6 minus root 3 by 2 2s are 4 into R square. Okay, this is the formula to calculate area of a circle, segment of a circle for theta is equal to 60 degree, that is pi by 6 minus root 3 by 4 into R square. See, if you know the radius of a circle, the corresponding segment can be calculated by using the formula pi by 6 minus root 3 by 4 into R square when theta is equal to 60 degree. Is it clear? So, if you don't know this formula, okay, this should be carefully studied because this is only thing we needed to calculate the area of the segment for theta is equal to 60 degree. Next, we are going to calculate the area of the segment when theta is equal to 90 degree. For that, I am going to substitute here theta as 90 degree. Okay, for theta is equal to 90 degree, as usual, I am substituting theta 90 degree by 360 degree minus sin 90 by 2 45, sin 45 and cos 45 is 1 by root 2, 1 by root 2 into 1 by root 2 into R square. Here 90 4 times, that is pi by 4 minus root 2 into root 2 2 into R square. Okay, this is the formula for calculating area of the segment when theta is equal to 90 degree, that is pi by 4 minus 1 by 2 into R square. Okay, for these two formulas definitely you have to substitute or you have to take the value of pi as 22 by 7, even if 3.14 sometimes in the question paper they may given, but it would be better to calculate the area of the segment if you are applying this formula, okay, that pi as 22 by 7. This formula can be further reduced. Okay, that means if you substitute this pi as 22 by 7, let us see. Okay, that is A is equal to 22 by 7 and 4 in the denominator minus 1 by 2 into R square. Okay, so here 11, here 2 times, that is 11 by 14 minus 1 by 2 into R square. Okay, so multiply with 7 in order to make like fraction. So 7, here 7, that is 11 minus 7, 14 and 14. So subtract the numerators by keeping the denominator same into R square, that is 11 minus 7, that is 4 by 14 into R square, or 2 by 7 into R square. This is the area of the segment of a circle for theta is equal to 90 degree. So we have reduced this big formula into very small one, that is 2 by 7 into R square. Okay, the children those who are struggling for completing the paper examination, lack of time, you can apply this formula. You can easily get the answer. Okay, 2 by 7 into R square. Okay, this is only for when theta is equal to 90 degree. Otherwise, you can use this formula and substitute. You have to write all these steps and finally multiply with the R square. You can easily get the area of the segment for theta is equal to 90 degree. Okay. So, these are the areas related to circle. that is area of the whole circle pi r square, area of the semicircle pi r square by 2, quadrant of a circle pi r square by 4, and area of the sector, that is A is equal to theta by 360 into pi r square, and area of the segment when theta is equal to 60 degree, pi by 6 minus root 3 by 4 into r square, for theta is equal to 90 degree, pi by 4 minus 1 by 2 into r square, or 2 by 7 into r square. These are the formulas to be by hearted for solving the problems of the remaining exercises. Okay. Before we moving to the exercise problems, okay, some more points to be explained. The first one is the angle described by the minute hand of a clock. Okay, clock is almost like a circle, the dial of the clock. Okay, here 12, here 6, 9 and 3, in between 1, 2. Okay, we need only this marking only. Okay. Okay. So, the minute hand, that means in between 12 and 1 you can see 4, okay, including 1, 5. Okay. Yes. So, the minute hand from this 12, it moves to this first part. So, what is the area, the angle described by the minute hand after 1 minute? Okay. So, that means in 1 hour, that is the complete angle, that is circle. So, the complete angle, the 1 hour, the angle described by the minute hand in 1 hour is equal to 360 degree, right? So, 1 hour can we need 1 minute. So, we can convert hour into minute, that is 1 hour is 60 minutes. So, 60 minutes, in 60 minutes this is equal to 360 degree when it completes 1 hour, in terms of minutes 60 minutes. So, in order to find the angle described by the minute hand in 1 minute, okay, you have to divide 360 divided by 60, that is 6 degree. Okay, so, the angle between these two lines is 6 degree. That is the angle described by the minute hand of a clock in 1 minute, that is 60 degree. So, in 10 minutes, okay, so that you can easily calculate the angle and you can also calculate the area swept by the minute hand after 10 minutes. Okay, 10 minutes or 5 minutes. Okay, 5 minutes means it will be at 1. Okay, if 1 minute 6 anengil, so in 5 minutes, that is 6 into 5, 30. So, here the angle between these two, that is radii, if you take they are in terms of radius, so the theta will be 30 degree. Okay. So, if it is 10 anengil, multiply with the 60 into 6 into 10, like that. And if in 15 anengil, if it is 15, okay, 6 into 15, that is 90 degree. So, quadrant ideas, quadrant means 90 degree. Okay, 4 quadrants make the complete angle 360 degree. Okay, so in the same way, the angle described by the hour hand, okay, in 12 hours. 12 hours means, if it is hour hand, if you are talking about our hour hand, this is equal to 360 degree. So, 1 hour, okay, that this is equal to 360 degree divided by 12, that is 30. Okay, 30 degree. Okay. So, these are very important, that is angle described by the minute hand in 1 minute is equal to 6 degree. So, that you can easily calculate the required measurements. Okay. In terms of hour hand anengil, you divide 360 divided by 12 instead of 60, because we need in terms of hour. So, 360 divided by 12, that is 30 degree. So, 2 hours. Okay, 2 into 30 degree, that is 60 degree, that angle. So, you can easily calculate the area of the sector or arc length, whatever is needed, you can easily calculate the theta, the angle described by the endpoints of the arc at the center. Okay. And the another very important point is about that we already know how to calculate the area of the ring. Okay, the ring is a concentric circle, okay, with a different radii. Okay, so what, and if the inner ring has the radius small r and outer ring capital R. Okay, we know the area of this outer ring, that is pi capital R square minus pi small r square. This is area of the ring. You can take pi as common, r square minus small r square, a square minus b square, that is r plus r into r minus r. This is the area of the ring. Okay, these are the main theory sections in this lesson. Okay, so study well, and we will solve the exercise problems in the coming videos. Thank you for watching my video. Thank you all.